So previously we saw that if you had two convergent series and you added them together or subtracted them, they would also be convergent. And I had mentioned that if they were two divergent, they don't necessarily combine to be divergent. But we do know these two useful facts. One is, the first one I think is kind of obvious. If the sum doesn't add up to anything, multiplying it by a constant is not going to make it add up to anything. Unless the trivial case, multiplying by 0. If you take every term in that series and multiply by 0, then it's 0 plus 0 plus 0. That will converge to 0. But in general, if it's divergent, a constant multiple, non-zero multiple, will still be divergent. And then the second fact is about the adding or subtracting. If one of the series is convergent and the other one's divergent, a sum or difference will be divergent. So let's look at this example. It looks almost like the one I did for the properties, except for now, notice that when you break this up, you have two geometrics again. This one convergent, because absolute value of r is absolute value of 3/4, which is less than 1. And the second one, though, also geometric, but divergent, right? Because the r in that case is 5/4. So this is a divergent geometric. Absolute value of r is absolute value of 5/4, which is less than 1. No, it's not. It's greater than 1, right? That's why, and actually, the criteria for divergence is that that needs to be greater than or equal to 1, right? If this r is actually 1, it's divergent as well. So when you do make this argument, make sure you say greater than or equal. That shows me that you understand that the condition is, for divergence, that the absolute value of that be greater than or equal to 1. But now what do we know? We have a series that can be broken up as two series summed together, one of which is convergent, one of which is divergent. And so by that fact, we know that our series diverges. And again, our text does not present these as a theorem or anything, just a fact, useful fact. So you don't have to say, quote any theorem or anything. You just say that that series diverges. So I do want to see, you do need to make an argument about the two individual pieces, about how you know one converges and how you know the other diverges. But once you've done that, you can just simply conclude that your series is divergent. And so just be careful. I'll warn you one last time. The sum or difference of two divergents, if these are both divergent, then nothing we have so far is going to work, unless maybe nth term test. But if they're both divergent, there's no property for that. You'll have to do some sort of theorem or test on it to figure out whether it's convergent or divergent. Because the two divergents could combine together to sort of cancel each other out to converge, or they could reinforce each other to diverge. So it really depends. So yeah, a convergent plus or minus a divergent is going to be divergent.